So the question says a current carrying wire passes through a region of uniform magnetic field, magnitude 0.05 Tesla. So the best thing is we start writing whatever is given in the question. So 0.05 Tesla as the value of B, and as a result experiences a force of magnitude. So force experienced is 0.03 Newton, and the question therefore is, what is the current I? So do you remember the formula that connects all three of them together? So the expression is given by vector force F will be equal to L times vector I cross vector B. Yeah, and if we have to remove the cross sign, then we have to put the expression as magnitude of the force F will be equal to L times I B sine theta. What is theta? Theta is the angle between I and B, the smaller angle measured from I to B. And what is the value of angle theta over here? So we are given the direction of the current passing like this, and magnetic field is entering into the page. So definitely over here the angle theta is equal to 90 degree. So when theta is 90 degree, sine theta will be equal to 1. So we can write our expression as F is equal to LIB. And now from here we should be able to easily calculate the value of I. So that means I will be equal to F divided by L times B. But wait a minute, is the L given to you in the question? So what is L? L is this length of the wire, but in terms of the triangle P, Q and R, in this right angle triangle, this value 30 degree angle R. So can we make use of this to find the value of L? So in that triangle PQR, what will be the value of sine 30 degree? So sine 30 degree will be opposite side, which is PQ, divided by hypotenuse. That will be L. And we know sine 30 value is 1 by 2. That will be equal to PQ. That value is also given to you. That is 0.2 divided by L. So from here we get L is equal to 0.4 meters. So put this value of L into the above expression and then you will get the value of I. So I will be equal to force, which is given as 0.03 newtons, divided by L, which we just calculated the value as 0.4, and multiplied by B, which is 0.05. So if I multiply the numerator, this is my way of doing the calculation. You can use whichever way you like, and the denominator by 100, you will get it as, this will be equal to 3 divided by 0.4 into 5. So which in turn will be equal to 3 divided by 2, and which is actually 1.5 ampere. Alright, so the answer is option A, which we just calculated. The value is 1.5 ampere. So that's a step-by-step way how you arrive at the answer, but you should always try to have an opportunity to be able to verify your answer. Can you verify with these given values with 1.5 ampere? Can we verify if our answer is correct? So put all the values in this formula, if I can call this as maybe equation 1, and see if you get the value as 0.03. So F with this option will be L which we just calculated as 0.4 times I 1.5 times B is 0.05. So that will be equal to, if I can put all the decimals away, so this will be 4 into 10 power minus 1. This will be 15 into 10 power minus 1. And this will be 5 into 10 power minus 2. So how much that comes to? This is 4 times 15 is 60, and 60 into 5 will be 300 multiplied by 10 to the power of, this is minus 1, so minus 2 minus 4, and this will be equal to 0.03 Newton. So which in fact is what is already given in the question. So we are able to verify that with the answer as 1.5 ampere, the answer is correct. We are able to get the same value of force if we put the value back in the expression. So always try to verify your answer as much as possible. So with this, we conclude on this answer.